Why is Linux 30x faster than Windows 10 in copying files? I got 20.3 gig of files and folders totaling 100k plus items. I duplicated all those files in one directory from Windows 10, and it took me an excruciating 3 hours of copying. Done. The other day, I booted in Linux Fedora 24, recopied the same folder and bam. It took me just 5 minutes to duplicate it on the same place but different directory. Why is Linux so fast? And Windows is painstakingly slow? There is a similar question here. Is Ubuntu Linux file copying algorithm better than Windows 7? But the accepted answer is quite lacking.
The basics of it break down to a few key components of the total system: the UI element, the graphical part, the kernel itself, what talks to the hardware, and the format in which the data is stored, i.e. the file system. Going backwards, NTFS has been the de facto for Windows for some time, while the de facto for the major Linux variants is the extension file system. The NTFS file system itself hasn't changed since Windows XP 2001. A lot of features that exist, like partition shrinking, healing, transactional NTFS, etc., are features of the OS, Windows Vista 7, 8, 10, and not NTFS itself. The extension file system had its last major stable release, Extension 4, in 2008. Since the file system itself is what governs how and where files are accessed, if you're using Extension 4 there's a likely chance you'll notice an improvement to speed over NTFS. Note however, if you used Extension 2 you might notice that it's comparable in speed. It could be as well that one partition is formatted in smaller chunks than the other. The default for most systems is a 4096 byte 1/2 cluster size, but if you formatted your Extension 4 partition to something like 16K3 then each read on the Extension 4 system would get 4x the data versus the NTFS system, which could mean 4x the files depending on what's stored where, how and how big, etc. Fragmentation of the files can also play a role in speeds. NTFS handles file fragmentation very differently than the extension file system, and with 100k plus files, there's a good chance there's some fragmentation. The next component is the kernel itself, not the UI, but the code that actually talks to the hardware, the true OS. Here, there honestly isn't much difference. Both kernels can be configured to do certain things, like disk caching, buffering, to speed up reads and perceived writes, but these configurations usually have the same trade-offs regardless of OS, e.g. caching might seem to massively increase the speed of copying, saving, but if you lose power during the cache write, or pull the USB drive out, then you will lose all data not actually written to disk and possibly even corrupt data already written to disk. As an example, copy a lot of files to a fat formatted USB drive in Windows and Linux. On Windows it might take 10 minutes while on Linux it will take 10 seconds. Immediately after you've copied the files, safely remove the drive by ejecting it. On Windows it would be immediately ejected from the system and thus you could remove the drive from the USB port, while on Linux it might take 10 minutes before you could actually remove the drive. This is because of the caching, i.e. Linux wrote the files to RAM then wrote them to the disk in the background, while the cacheless Windows wrote the files immediately to disk. Last is the UI, the graphical part the user interacts with. The UI might be a pretty window with some cool graphs and nice bars that give me a general idea of how many files are being copied and how big it all is and how long it might take. The UI might also be a console that doesn't print any information except when it's done. If the UI has to first go through each folder and file to determine how many files there are, plus how big they are and give a rough estimate before it can actually start copying, then the copy process can take longer due to the UI needing to do this. Again, this is true regardless of OS. You can configure some things to be equal, like disk caching or cluster size, but realistically speaking it simply comes down to how all the parts tie together to make the system work and more specifically how often those pieces of code actually get updated. The Windows OS has come a long way since Windows XP, but the disk subsystem is an area that hasn't seen much TLC in the OS across all versions for many years, compared to the Linux ecosystem that seems to see some new FS or improvement rather frequently. Hope that adds some clarity.
If you want to support the channel, please consider liking and subscribing.